my channel. So in this video, I'm going to cover two things. The first thing is we should cover the solution to this problem, and then we are going to do some coding work. And the second one, I'm going to cover the general procedure to following the coding interview briefly. So before we start the real content for today, I would really appreciate that if you can help subscribe this channel because it can help me to grow. So thanks in advance. Let's read through this problem. So remember, in the real coding interview, the first step is always trying to understand the problem. So don't jump into the coding part too quickly. Try to fully understand the problem first, and if there's anything unclear, please bring up the question to the interviewer. And at the same time, think about some edge cases. So let's say, remove subfolders from the file system. So give a list of folders, remove all subfolders in those folders and return in any other the folders after removing. Okay, so if a folder I is located within another folder J, it is called a subfolder of it. So the format of the path is one or more concatenated string of the forms / followed by one or more lowercase English letters. For example, /Leetcode and /Leetcode problems are valid passes, while an empty string and / are not. Okay, so let's see, we have this something like this. Finally, after removing all the subfolders, we have /a and /cd/cf. Okay, so that's because ab/ab is subfolder of /a/cde is a subfolder of cd. So similarly for example 2, 3. Okay, so let's see some constraints. It says that the folder the length is between 1 to 4 times 4 to the power of 4, which is 40k. Okay, so folder's length is between so each folder the length for each of the folder, the length of the string is between 2 to 100, and it only contains lowercase letters and / always starts with character /. So each folder name is unique. So it says that we don't have we don't have the root, so we will never have the root directory as a folder, because it says that just one / is not valid, and also each folder, the length of each folder is going to be larger than 2, which means the root folder is not included in here. So I think the next part is about doing some solution finding stuff. So how to solve this problem? So one thing I think we could do is, let's say the solution 1. What we could do is we can do a sort based on the length of folder, and then we can try to see if one folder is any subfolder of the previous folders. So for example, first of all we sort, let's say we take this example. First of all, let's sort it. So we are going to have /a, then the second one is this, third one is this. So by the way, we are going to sort by the length first, and then if the length is the same, then we are going to do the sort by alphabet. So when we go through this, first of all, after sort we go through A, and then we see AB. So AB, of course, it is the subfolder of /a, so we are going to remove it. And then we have CD, we have CF, and then when it comes to CDE is a subfolder of CD, so we are going to remove CDE as well. So I think it should work, but the runtime is going, let's say we have the length of the input string array is going to be n. So because of the sort, it is going to be n log n. And also, let's say for each of the subfolders, suppose we have like each of the string that has n levels of the m levels of the folder, then we also have like n times m. because it's like we need to see first we need to see if /c is contained in the previous previous folders, if /cd is contained in the previous folders, if so we need to like see all of the parent folder is any of the folder that comes before it in this solution. So I think this one it might be a little bit inefficient, but let me go through another one. So let's say the solution 2. So due to the sorting, we have an nlog in here for solution 1. So next one, the next solution I can think about is we could use Prefix Tree, which is try. We could use try to solve this problem. So first of all, we build a try by going through everything, and then after we build a try, we go over each of them again. So let's say when we go over CDE, we see that in the prefix tree, there is already a pass from C to D, and CDE is just a child of that folder. So we are just going to ignore this one. So this regarding this one, the runtime is going to be n times m. Essentially, we need to go over each of the thing to build the tree, build a try, and then we go over again to see if the corresponding folder has the corresponding folder has a parent folder that is included in the tree. So overall, I think it depends. So it depends if the login is larger than m, then I would say, yeah, if login is larger than m, I would say it is the first one is inefficient. But in case login is like about the same as m, then I think the two approaches regarding the runtime, they're just the same regarding the runtime efficiency. So let's do the coding work for solution 2 because it's a bit more challenging. So we need to implement the try for this problem. So the next part is about doing some coding work. So for coding, care about the correctness of the code, the readability of the code, and also don't be too slow. So let's define a class, call it try. So in this one, try is going to have the children. So the children, let's define it as a map from the character to the try node. Let's say we define the try node to try node. Okay. So this is children. Okay. And then we also need to have a boolean representing if it is a folder. So it is folder. Okay. Let's give it a constructor. Let's say the try node. This folder as so we have the children. As new hash map, and is folder set as false, or you could say have another constructor here. So is folder so we have this, and let's define another helper function here. Let's call it insert. So this one is going to not to return anything. So we are going to have like the string, let's say dir. So for the dir, first of all, we are going to split it. So string, I would say, let's say it is a chunk, is going to be split with the slash. Okay, I think it's just slash / and then you're going to say, okay, go through each of it. Well, we shouldn't define it here, actually. Let's define another thing, which is a try, the try. So for the try, we will have a public, let's say we have the try node as a root, and then we have the root, and we will have the constructor. So try new try. No, okay. So here, let's define a helper function. Let's say insert. So the insert is going to, the parameter is going to be the father, and then for the father we will need to split it using the / So let's say this is a chunk, father dot split, and then we need to go through each of the chunk here. This is chunks. So we will have here, let's say the try node is equal to root at the very beginning, and then what we are going to do is if the node dot children dot contains key chunk, then we are just going to say, okay, node is equal to node dot children dot get chunk. Otherwise, if it doesn't contain the chunk, what we are going to do is we are going to say, okay, node dot children dot put the chunk into it. This is of course a new try node, and we are going to have node is equal to node dot well, we could actually save some code here. So if it doesn't contain this, we are going to put the new node, and anyway we are going to have the node is equal to node dot children dot get chunk. Okay. Yeah, so after that, I think what we are going to do is we are going to have node dot is father as true. So let's say, suppose it is AB first, it goes to, suppose it's /A, then at the very beginning it doesn't have the A, so we are going to put the A and the corresponding new node into the children of the root, and then we go to the corresponding child, and then we will after that we are going to set the corresponding try node as true. Okay, so that's pretty much about the insert, and we also need to define another helper function. Let's say the helper function is to see whether there is already a subfolder. So let's say I pass in a parameter. It is going to see let's say it is subfolder of a folder. So So suppose we have already built the tree, already built a try. So we are going to, so this function is to tell whether there is any folder that include this folder and in the try here. So for example, let's say we already have the /a. If you pass /ab, then we are going to return true here. So again, we are going to split it into the chunks. Folder split. Yeah. So one thing I need to think. Okay, so it says that each folder is going to be unique, so we don't need to worry about the duplication stuff. So for the chunks, let's say we have the try here. So we're going to have the try node as equal to the root here at first. Yeah, so if the so let's see, node should be equal to node.children dot get the chunk. So let's see, if so let's say if we already have the slash, let's say there are only two things, /a and /ab. So we have this one, we have built this stuff, and then let's say if it is /ab, we should return false. Well, let's say first of all we go into a, and then we go into b. So if we go into b, we shouldn't, so we should check first, I would say. So if node dot is father, then we are going to return true, otherwise we are going to return false. So let's say we have /a and /ab, and we form the tree at the very beginning. So when we tell whether /ab is a subfolder, so first of all it is a root, and we see, okay, root of course is not a folder, so we are not going to touch this one. Then we go to the corresponding subfolder, which is /a. /a, it is a subfolder, so we are going to return true here. But let's say if we only have /ab here, we only have /ab for the try, then /a is not a something. It's not /a is not within the try, so we are not going to touch this one. And then if it is /ab, and then we go to the b. Okay, yeah. So what I just want to see is we don't want to say we don't want to have introduce some false positive. So let's say we have the /a/b. We want to make sure that when we touch /a/b again, it is not going to return a subfolder as true. Alright, so having said that, I think it's okay. So next thing for us to do is to use the defined class to really solve this problem. So we are going to say, okay, it's try is equal new try, and then we go through everything, string dir. Let's say we change this as fathers. So try dot insert the father, and then we have define a list of the string here. Let's say re is new linked So you're going to go through this again. If Troy dot is father, then we are going to return. We are going to continue. Otherwise, we are going to already add the father. So finally, return re here. Alright, so that's pretty much it, I think. Let's do some testing. So it says that string chunk. Okay, so it is not character, so it is string actually. This is stuff that's not right. Alright, so it seems to be okay. Let's do a submission. Alright, so it seems like everything works well here. So it's just a try approach. So remember, after you're done with coding, please do some testing. So for simplicity, I just rely on this platform to help do the testing. But in real interview, you don't have this kind of platform, so you need to set up the test cases yourself. So that's it for this coding question. If you have any question regarding the solution or regarding anything, feel free to leave some comments below. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.